encoding, guys. Encoding, in a sense, we are going to convert the categorical column to the numerical column. Let's see df dot head. It looks like both of them are numerical, but still I want to find out df dot d types. D types, what it will do is like each column, what is the data type? It will get us. So you can see this float and float. Okay, it is float and this is float. Both of them are float. Then that's okay. Now here there is no need of converting anything. Then I will do the data separation. What do you mean by data separation? We are going to split the data into independent and dependent columns. Dependent and dependent columns. So here we will do it as df dot head. If you check it out, we are having this is the height column, which is independent. This is the weight column, which is dependent. So height column, I will get it in the X. Weight column, I will get it in the Y. So df square brackets height column. Here, this is the height. I will put it in the X. But here you should understand one thing, guys. Always remember X should be in data frame format, or in other terminology, it should be a 2-dimension. Okay, it should be in 2-dimension. You can't keep it as a 1-dimension. So this is a problem with this. So what we are going to do it is, in order to make, if I take it like this, single square bracket, it will take it as a series, but X should be always in the data frame format. So to make it data frame, do it in the double square. Okay. Now, if you have multiple columns, no need to do this. Directly, it will be in data frame. But if it is a single column, you will be getting in the series. So I will put it in the double square brackets to make it in the data frame. I explained this one in the one-hot encoding, and I explained this one in the ordinal encoding, because there we will give the input in the double square brackets. Now you see this, this is X. Now, if you ask me, show me the data type of this, see this, print type of X, capital X. Now you will get it as data. Now, series, now Y can be in the series format. Y you can give it as series format, like a. Okay, now you can see this. Y I will put it as print Y. Let me show you the Y first, and I will put it print type of Y. Type of Y series. Okay, now that's fine. Now here, next thing is we don't have balance, because imbalance will be checked with the classification problem. This is a regression problem. Regression problem means the dependent column will be in continuous numerical value, that is a float. So our dependent column is weight. You can see this. It is a continuous numerical. Okay. Now here we are going to do the data splitting. Okay. Now here I will give it as df like from sklearn dot model selection model selection, import train test split method. Train test split method. Here I have it x comma y comma test size. You know this, what I'm doing? I'm splitting the data into training set and testing set. Okay. I'm giving it over here 0.20%. And here you will take it as by train, by test. Now, 80% will be training side, 20% will be testing. Okay, you will be getting it. Now, I will show you this equation also. Now, if you take it x dot shape, how many are there? 9,990. Now, if I take it x train, should be 80% of your training data. And x test should be 20%. Now, at the same way, y dot shape should be 9,993. Y underscore train dot shape will be 7,990. Okay. Now, if you take it y test dot shape 1,990. Now we have done it. Now we are going to build a model. Model building. Okay. And model building, we are using the linear regression. So from sklearn dot linear model. Guys, remember always all these imports, all the imports should be there at the starting where we are starting what we are doing over here. Here you should have all of them. That is the quality of a good programmer. If you want to show some stuff, then you can do it from here. Okay. And the one more important thing is please maintain your GitHub account. Now we are doing one after the other, this one, right? Every day you upload your code in that. Okay, every day 1 or 2 or something like that. That will help you a lot and lot. Okay, please maintain that. Import linear regression. I'll share you the code like questions based on the algorithms also. You can please practice them. Then automatically by the end of ML, you will be perfect with the ML from the interview process. And the same thing I will do it with the deep learning also. Okay. Now here, linear regression, I will give it as LR model. LR model is nothing but my linear regression model. Okay. Now this model, we got it, we created, that's it. You import it. Okay. You import it and just do this. That's it. Now here, what we will do it is LR model dot give the data. Data we will be giving using the fit function. What data you will give it? Training data. This is X train and Y train. That is, you can take this as these are questions and these are answers. You are giving it and it will learn from it. Okay. Now, then I will find the score. LR model dot score. Here I will give it as X test and Y test. 84% accuracy we got it. Okay. Now, let's see one more method of finding the accuracy. I told you yesterday here. Let's see the R square. Okay, R square method. Here I'm using R square method. Now, one thing you should understand, guys, R square will work with only regression. R square, this mean standard, mean square error, root mean square error, mean absolute error. This all will work with only regression. Okay, it will not work with classification. When I'm using the score, this will work with your classification as well as your regression. But you know that in the interview, they will ask you this. What is the purpose of R square? What is the purpose? That's what I'm showing you. How you will get the R square, how you will implement. From sklearn dot, there is something called as import. Okay, I will use the R square here. R, and we are having something like mean squared error. Can you see it here? And mean absolute error also. Mean absolute. You can use it. You can use them whatever you want. I showed you over here. Mean square error, mean absolute error, mean root mean square error, all root mean square error. Let's see that. Root mean square error. You see this. Okay, anyhow, now let's implement with R square. So what you will do it with the R square implementation is, first you take your LR model. See guys, try to understand this. This is getting the score, accuracy score. What do you mean by this is, if you are going to ask 100 times, this will give you 84 times correct answer. Yeah, 16 times it may lose that one. That is 84 times it will give you the correct answer. Now I'm trying out the same accuracy with the different methods. Okay, that is R2 score I'm using it. First, this is my model. This model is trained with already data. Now what I'm doing is LR model. This is one way of finding. This is the easiest way. Okay. Now this is the other way of finding the score. Don't get confused. Now from here on, we will be doing this all, so you will not get confused. Okay. Now LR model dot predict X test. Now what I'm saying is X test data is there. These are questions. See, this one is question and answers we gave it to the model. Model learned from this. Okay. Now this I will explain you what is going on later. Now here in this case, you are giving only questions and asking this model tell me the answers. Now you see this, it will tell you the answers. Saying the answers. Yeah, if there are dots are there, like all 9 or how many are there here? 1999 answers. Now this you will store it in a Y predict. Y underscore predict. What do you mean by this is? This is predicted by my model. Okay, now you see this Y predict. Y predict. Now here we got it Y predict. Now this is predicted by this. And Y test is there, right? We are having something called as Y test. Y test is the actual answers. So I will compare this one with my Y test. How to do that? R2 score Here you give it your y test, comma, y predict. Y test is actual answers. These are the answers what is given by my model. Let's see what is the accuracy. 84%, 7. The same accuracy scores. Okay. Now let's see how our mean square error works. Now here also we are going to give it y true and y predict. Y true means y test, comma, y predict. Y test is y underscore test, y underscore predict. Right. Now let's get it. This is saying 155. Now, what is this 155 is nothing but, understand this. This is the squared and mean error. Error which is mean error. Now I will tell you. See, if you take it calculator, 155, how we got it over here? If you remember here, I explained you. First we were getting it all zeros. So we applied the square and then we distributed it by using by dividing it by pi. That is mean square. That is, it is a squared value. So I'm removing the square from this. I'm applying the square root. 12.44 is the error. If you remove the square root, the error is 12.44%. So my accuracy score is increased to, you can say it as 87%. Okay. Now, if you minus 100 from this, you see 87% is my accuracy. Okay. That is the way it is giving us. And if you go with mean absolute error, here also it will ask the same y predict and y true and y test, comma, y predict. Now you can see it is calculating the error is 9.89. That means this is the error percentage. So from 100 you remove this, it will be 90% accuracy we are going to get. We are going to get 90% accuracy in this. So in this, we are getting the accuracy as like 88% or 87% we are getting. In this, it is showing the accuracy directly of 84%. Okay. Now, if you check it out, root mean square error. Let's check this one also. Again, this I will give it as y test and y predict. Not defined. Okay. You check it out over here. I got it 12%. The same error we got it, what we calculated, 12.4. This is the error over here. This is error. Okay. This is giving us the direct accuracy. This is the error, but here the square is there. I removed the square. I got the same thing, 12.4. This is the error. This is the okay. Now error, it should not. They are having different mechanisms. We can't say that all of them will be the same errors. Okay. Chalo. I will stop it over here, guys. And it is already there in the drive. And tomorrow I will inform you, or mostly, as I said it, we may not have the class tomorrow and day after tomorrow, but still, if I have some time, I will inform you so that we can have, and because I'm traveling today. Okay. Thank you very much, guys.